welcome back. Here in this room, we will hear Tino. He's speaking about how to build hybrid clouds and federated environments. So, thank you.
Hi everyone. Well, thanks for coming to the OpenNebulaConf and to this talk. Yeah, my name is Tino Vázquez, and I work for the OpenNebula Project and also for OpenNebula Systems, which is the company behind the OpenNebula Project. So if you have a production environment based on OpenNebula and you need professional support, we are your guys. Okay, so today I'm going to talk about the hybrid connectors of OpenNebula to manage virtual machines on public cloud environments. So I know many of you already used OpenNebula, but how many of you ever tried to deploy VMs in Amazon, for instance, using OpenNebula? 3 people. Nice, okay. So did it work? Yeah, good news. Yeah, it does work. So this is going to be just some brief introduction on the hybrid approach of OpenNebula and some live demo of the different connectors that we have for the different public clouds that we support, namely Amazon EC2, also IBM SoftLayer, and Microsoft Azure. So, yeah, as I said, this is the brief agenda of today's talk. So, the hybrid approach in OpenNebula, it's quite unique, I think. We focus on the transparency under 2 perspectives, for the administrator of the cloud and also for the end user. So what does it mean for the administrator to be able to manage public clouds transparently? Well, for OpenNebula, public cloud is modeled as an OpenNebula host. So as a local hypervisor, you'll see, if you do a one host list, you'll see your local hypervisors, your local nodes, and also any public cloud that you have defined in your OpenNebula system. And for the end user, the transparency it's performed through hybrid VM templates. And what's a hybrid VM template? Well, it's basically a template that describes a virtual machine locally, so the traditional VM template in OpenNebula, where you define the capacity and you define the disks and also the networks. But also you can add sections of representing the same virtual machine in different clouds. For instance, you can have the EC2 section describing for instance, the identifier of the AMI of the image that you want to launch. The same thing happens for SoftLayer and also for Azure. So, well, we'll see what's the reason behind this and how this can be used to represent different, to be more accurate, the same virtual machine in different public clouds and also locally. So, one OpenNebula host, one of the host pool in OpenNebula can contain different entries, and they can mean different things. So you can have your local hypervisor modeled as a host in OpenNebula. That's the traditional use of the hosts in OpenNebula. So if you use OpenNebula, you know that you can add a physical server with, for instance, a KVM hypervisor installed, or you can add an ESX VMware hypervisor also as a local host, and also the Shen hypervisors. Those are the 3 hypervisors that OpenNebula supports. But also, you can have an OpenNebula host describing one public cloud, for instance. And you can also, you have a finer grain control of what are you modeling. You can model the whole Amazon EC2, for instance, which can be a little bit crazy. But you can partition it by representing a special region in EC2, or a location in Azure, or a data center in SoftLayer, which is basically different ways of these public cloud providers of defining these geographically regions, right? And also you can partition it further by representing just a specific availability zone, for instance, in Amazon EC2. Okay, so under the end user perspective, end user just is presented with a list of VM templates, for instance, Ubuntu 14.04, for instance, or something like that. And these VM templates are prepared by the administrator with this information of what does it mean, this machine, in different local hypervisors or in different public clouds. And the administrators can control how this the placement is done. So, for instance, we offer some predefined scheduling policies. The one that makes more sense, at least under our point of view, is the fixed priority, where basically what's going to happen is that OpenNebula will schedule the virtual machines locally until the local infrastructure is running out of capacity, and then it starts to outsource VMs to the public cloud, because obviously it costs money and it's desirable to run them locally first. And if that's out of the question because there's no more capacity, then OpenNebula will start firing these VMs in some public cloud that you can obviously also control. And also, the administrator is able to define the capacity of the public cloud. So, for instance, you can tell OpenNebula, okay, this is the whole of Amazon EC2, but for you, it's going to be just a small public cloud where you can fit 5 virtual machines of 2 CPUs and 2 gigs of RAM, for instance, right? So this will somehow control the cost that OpenNebula is going to consume in public clouds, and it's going to limit the number of virtual machines that it's able to launch, for instance, in SoftLayer, so your credit card doesn't suffer a real hit if lots of users start firing virtual machines all of a sudden. Okay, so this is how OpenNebula models the public cloud and how end users consume these VM templates. But, well, obviously, OpenNebula doesn't do any magic, so there's some limitations that apply here in hybrid environments. So, for instance, things that the administrator has to take care of is networking. So OpenNebula won't create a virtual network that expands from your local data center to Amazon and to SoftLayer and creates a magic interconnection between all of your VMs. So you have to work a little bit before and define, for instance, a VPN that will connect all the virtual machines. And obviously, you have to do some benchmarking and see if the latency that this layer imposes to your services is acceptable or not. And then you have to act on consequence. So you can define a service of a web server with different nodes, load balanced, and you can have them locally, and as soon as, I don't know, the number of connections per second surpasses a certain threshold, then the one-flow component, which is the component in OpenNebula that manages services and elasticity rules, may decide to create new web server nodes, for instance. So if the infrastructure is saturated, it may decide to launch them in Amazon. So it's up to your previous work to see if that's acceptable or not. Maybe creating nodes in Amazon and enrolling this web server will introduce a latency in your service that will render it unusable. So you have to first to take that into account, maybe even decide that you have to switch off your local virtual machines and launch the whole service in Amazon. So OpenNebula allows you to define these types of policies, but it's, at the end of the day, depends on the service that you want to deploy with OpenNebula, and decide if this possibility of growing in Amazon or SoftLayer or Azure is something that your service can take or not. Okay, so this is networking. Another aspect of that OpenNebula doesn't cover is the automatic image upload, and we get this a lot, saying, okay, I have my local image in OpenNebula, and I want it to upload it to Amazon. Say, okay, you have to take that image, upload it with the API tools or whatever they're called, and once it's up in S3, for instance, and you have a registered AMI, then you can tell OpenNebula, okay, this virtual machine here in Amazon EC2 is the same virtual machine as this disk you have locally. And then you can create a VM template that describes both machines, which are in the end the same one. But OpenNebula won't take care automatically of this upload of the image. And related to this, it's also there's no inter-public cloud image transferring and converting. So you cannot say from OpenNebula, okay, this image that I have here in Amazon, I want to transfer it automatically to SoftLayer. Also, again, the administrator has to take up this task and transfer the image themselves, and then instruct OpenNebula and said, yeah, this image in Amazon is the same as this one in SoftLayer, so I don't care which one you fire. Just do whatever you think. Whatever you think is also you can also define by the scheduler policies, and you can create special policies, for instance, to take things into account that we don't, like for instance the cost. We don't take into account the cost of firing an image M1 small in Amazon EC2 or CCI small in Azure, for instance. But you can create these rules if you want and then contribute it back to the community. I think a lot of people will be glad. Okay, so how does a hybrid template look like? So as I said, you have first a section of the traditional VM template, which describes the capacity and describes the disk and the network. For instance, this is just an Apache normal web server that is connected. It has a network interface connected to a public network with a public IP address. Okay, so if OpenNebula is trying to place this template into a local KVM hypervisor, it knows that it has to copy that image and link that virtual machine to this network interface, and you have your web server running locally. But if OpenNebula doesn't find any spare place in your local infrastructure, it will try and go to another host, maybe the public EC2 host. So it will use that section of the template. So this is a reduced section of EC2. You have a lot more of parameters that you can control. And you define the AMI, also the instance type, so how big is going to be this virtual machine. And for instance, the key pair, the SSH key pair to access the virtual machine afterwards. The same VM template can also have different sections, for instance, for SoftLayer. So you can specify this template, this Azure template, SoftLayer template, that is also a LAMP server of medium size that is going to run SoftLayer if the OpenNebula scheduler chooses to launch it to a host modeling an IBM SoftLayer public cloud. And the same thing goes for Azure. You just define the image, also a LAMP server, an extra small, and with the AT port open. So this is more or less a depiction of what OpenNebula does with to create a virtualized infrastructure, potentially across different public clouds and also your local data center. So you see there local hardware, and you also see a missing logo for Amazon EC2, Microsoft Azure and SoftLayer clouds that OpenNebula knows because you added them as an administrator with the proper drivers to OpenNebula. And on top of that, you create a virtualized infrastructure, which are basically interconnected VMs that, as you can see, they can be living in different clouds, and they are connected through ad hoc VPN, for instance. Okay, so now one at a time, we're going to run through all the 3 supported public clouds. For instance, in Amazon EC2, what you need to configure, it's first you have to enable the EC2 drivers in 1d.conf. You have to install the needed gems. It's always, you can use the install gems script that is in user being share 1. And this is a Ruby script that will install the needed gems for Amazon or for SoftLayer or for Azure. And then, importantly, you configure the credentials. So these are the credentials that OpenNebula is going to use to manage virtual machines and to launch virtual machines in Amazon. You need the access and the secret access key. You can check that in your your AWS account. And it's basically two fairly big numbers that you have to input there. And you also model the capacity, right? So here we are instructing OpenNebula and saying, okay, this is the region US East one, and for us, for OpenNebula, it's going to be a hypervisor where it can fit only 5 M1 small virtual machines. As you see, this is the configuration of one region, but you can configure several different regions with different credentials and model them as different OpenNebula hosts. So you can have a host in OpenNebula defining the region US East, another one defining the region US West with different credentials and different capacities, depending on what are your expected usage and how much money you are willing to expend in outsourcing these VMs to public clouds. Okay, so once you have it configured, it's time to create an EC2 host in OpenNebula using the EC2 drivers for the information manager and the virtualization manager. And you see there that the network the network driver is a dummy driver because you are not able to define the networking through the normal OpenNebula network pool, but rather you do that through special configuration parameters. So these parameters are not the configuration parameters, but these are rather what OpenNebula extracts from the running VM. So you launch a VM, you waited for the monitorization, and OpenNebula will extract this information for the launched VM and present it to you through the command line interface or Sandstone. So as you see, you get information mostly about the networking. So here, most importantly, would be probably the IP address of the running instance. So you can connect to it afterwards. And as you see, there's different options which are all supported by OpenNebula. Like, for instance, tie this virtual machine to a specific virtual private network. Or also you can, extract information of the availability, so what this particular VM is running, or what's the given DNS name, or also what's the instance type. You already know because it's defined in the template, but it's more accessible. And let's go for just a brief demo. Okay. Okay, so this is a demo environment with 4.10 OpenNebula. We still haven't updated to the latest one. You can see here, don't copy those numbers, please. You can see the credentials for Amazon and the capacity. Gone. Okay, so, well, this is the EC2 specific configuration. And you can see here in the 1D.conf the enabled EC2 drivers. Okay, so if we go now to so here under the administrator view, you can see the different hosts here already added. So we have the EC2 US East Coast modeling Amazon as a host with 5 cores and 5 gigs of RAM. So that's the capacity of 5 M1 small instances. Okay, so once you have that, you can create a template. This template is representing a Red Hat 6.5 on Amazon EC2. You define that through the AMI number, and also you define the instance type. Okay, so this is it's as simple as that. Now you have modeled and an EC2 virtual machine in OpenNebula as a template. So users, I won't switch to the cloud view, but users can just launch this template. So now you are launching an EC2 virtual machine through the OpenNebula Sandstone in a transparent way. Here, I've set, for clarity's sake, the name of Red Hat EC2, but this can be easily just a Red Hat 6.5 for the user. He will launch it, and then he will connect to the IP address, and probably he won't even notice that he is connected to an Amazon EC2 instance. Okay, so this is waiting for the scheduler. Okay, so it's already running. So if we go now to the Amazon EC2 console, okay, we see here the virtual machine that I just launched that is pending in Amazon, is still waiting in Amazon for a suitable host. They have their own OpenNebula or something, nobody knows. And as soon as this virtual machine is up and running, OpenNebula that is constantly monitoring this virtual machine will extract the needed information, like for instance the IP address, so the users can connect to it. Okay, so this is for EC2, and the other two are fairly similar. So obviously the drivers are different, and the connection is different, but we made it so it's really transparent for the administrator and the end user. So even the configuration, it's quite similar. So basically, for Microsoft Azure, just enable the Azure drivers. Again, install the needed gems, which in this case are different from the Amazon EC2, obviously. And you just put your credentials. In this case, in Azure, you need a subscription ID and a certificate, a PEM certificate that you download from the Azure management console. And again, you can configure different regions with different credentials. So it's even if it's a completely different public cloud with different set of features, you configure them in OpenNebula the exact same way. Again, you add the host of your preferred region, and then you will get a set of different monitorization attributes. They start with a set, and they are basically host name, the IP address, the role size, for instance, the TCP open endpoints, and so on. So if you go to, well, we can launch also an Azure Ubuntu, for instance. As you see here, we are defining the SSH port to be in the 222, open the 80 port, you create a user, you assign it a password, and so on. You can change that, obviously, by updating the template. You will see there's a special hybrid section, and depending of the hybrid clouds you choose, you get different configuration parameters. So in this case, well, we are giving it the name of the template, which is a long string that Azure provides, and this one is modeling a 30 gig Ubuntu server. You define a user and a password, and you can take advantage of the special Azure parameters, like for instance, you can control in which storage account this virtual machine is going to run under, what's the cloud service this virtual machine is going to belong to. You can also tell the protocol of the Windows Remote Management connection for the remote desktop. So different public clouds offer different capabilities, and from OpenNebula, we treat them as template parameters, and this is a really powerful mechanism to fine-grain control the different features the public clouds offer. Okay, so I'm running out of time. Just going to briefly go through. Okay, Azure Live Demo is launching a template and seeing it in the management console. So the idea here is not to have different templates for different machines in different clouds, but rather to have one template here with 3 different sections defining the same virtual machine in different clouds. You will have an EC2 section defining the Red Hat, and for instance, an Azure section defining also a Red Hat, not a Ubuntu, because otherwise it will be a template that will create different machines depending on what public cloud it lands, and you probably don't want to do that. Okay, so just briefly, SoftLayer. Almost the same thing. You enable the SoftLayer drivers, you install the needed gems, you define the capacity of the different regions, and you put the username and the API key that will allow OpenNebula to launch virtual machines in SoftLayer on your behalf. Again, you create a host modeling a SoftLayer location, and you can launch virtual machines and get information back to you, like the user credentials, I don't know, some network information, max memory and max CPU. So this is a bit different in Azure. You can define the equivalent of the instance type, like M1 small, but you can also define explicitly the maximum CPU and the max memory that you want this virtual machine to consume. Okay, and the demo will be more or less like the other ones. Okay, so that would be all for my presentation. If you have any questions, I guess now it's the time.
Hi, Tino.
Hi.
So I'm from Runtastic, and our housing provider offers us burst cloud capabilities with vCloud.
Okay.
So are there any experiences with it, or is there a possibility for it?
So currently it's not supported. We don't have drivers for vCloud, but it's not the first time that we received that request. So I think the integration, I haven't looked into it, but I think the integration will be fairly straightforward, like these 3. It will be just a matter of building a driver to interact with the vCloud API. So for that, I will appreciate it. Do you know the Redmine development portal for OpenNebula? You can open there a request, a feature request, just briefly saying, I want to interface with vCloud, and we'll put it in our roadmap for the next release or whenever we can.
I just want to ask, what about when I create local guests, I can use the VNC function to like connect to the machine.
Yeah.
Can I also do that with external public clouds?
Unfortunately, no, you cannot. So yeah, the management and the end user experience is also a bit different. You cannot connect through VNC. You'll have to wait for OpenNebula to monitor and then access through SSH or remote desktop for a Windows. Yeah. Yes, that's the idea. I mean, you can even stop it because they support both 3 support that functionality, and yes, you can delete here this virtual machine, for instance, and after a while you should see it disappearing from also the SoftLayer control panel. So yeah, that's supported. There's obviously things that are not, like for instance, I think snapshotting is not supported because it's not offered by all of them or not in the same way. So we always try to give the minimum possible that it's available in all of them. So the management is as transparent as possible.
Just out of your curiosity, did you ever look at the Contrail project where there was a presentation last year?
Mm-hmm.
They have this conversion from one cloud type to another one and all this stuff, but I don't know if anybody ever tried it, and so I wonder if you tried it and didn't use it, or if just didn't try it.
No, I mean, me particularly, I haven't tried that. I know that some other members of the team were more involved in the Contrail project, although none of them were really in the project. So I'm not sure why we didn't take that. I don't know. I don't even know the license that they have. So in short, no. But it's a good opportunity. If they already done that job and they're willing to contribute it, then why not? I'll speak to them.
Okay, some more questions, or are we ready? Okay, thank you, Tino.
Thank you.